All right, now recording. And share the screen. Right. Game plan for today is I'm starting a new section, 9.1. 9.1. I talked a little bit about it yesterday. It will not be on tomorrow's test. Okay, so I'll lecture on 9.1. After a certain amount of time, I'll stop and let you ask questions pertaining to the test, and that's optional. So anybody who wants help, it'll just become like an office hour, and if you don't have any questions, you can just leave. Okay, so a reminder for the test tomorrow. Again, this is all repetition, but I'm saying it over and over, so there shouldn't be any excuse. And besides, sometimes students miss, so you didn't hear the announcements before. So our next test is tomorrow. Okay. Exam 4. Okay, coverage is chapter 7 and 8. We will not have exam 5 next Thursday. Okay, I know that for sure. So you turn 7.1 to 8.5 in for homework. I'll take it as early as right after class today. So once class ends today, if you already have this homework, you can submit it. Okay. So I will start the class with some lecture, see how far I get today. So I may lecture a little bit on 9.2. We'll see how far it goes. I'll stop very soon, probably like around 11:30-ish. And then you can ask questions up until 12. If there are no questions, or if the questions stop before then, we'll break early and we'll start the test early, so you have more than 50 minutes. Okay. As usual, I'll close the class at 1 o'clock, and then you have until 1:05. Take a picture on your cell phone of your exam, and then you have until 1:30 to submit the homework. But again, you can submit the homework early if you want. Okay, usual rules for the exams. I know we haven't had one in a while. So you can have one cheat sheet, one formula sheet, front and back, 8.5 by 11, both sides. And you can use a calculator, but other than that, no books, no notes, no people, no internet, no cell phone to help you, stuff like that. Keep your video on, true video, true background. Keep yourself muted. If you have a question, put it in the chat. If you have to step away for a break, go to the bathroom, get a drink of water, that's okay. Just let me know so I don't think you're off, cheating, getting some answers from somebody else. Okay. There's a 70% homework requirement. Okay. So if I do not get at least 70% of the homework, I will not grade your exam. It'll be a 0. Okay. And then, I look at the writing on the homework and the writing on the exam. Obviously, it should match. Again, I'm not a handwriting expert, but I can tell some obvious things. If the writing on the homework clearly doesn't match the writing on the exam, I get suspicious. Okay. And remember, I always have the right to call you out and say, well, I'm not sure if you really understood this or not. So come speak with me over Zoom. And then if I ask you a question on the test and you have no idea how to do it, but you got it right on the test, then I will suspect that you're cheating and possibly lower your grade because of that, right? And so that's that. So that's tomorrow. And I think I covered everything I need to cover. You can use a calculator. About 10 questions. That was true for all the previous exams, right? About 10 questions. And there are 10 sections. So a very likely scenario is I give one question from each section, right? And I did a mini review on yesterday's video also. Okay, so any quick questions about the format of the exam, please? Okay, I don't see or hear anything. So I'll start with 9.1. You can take notes or not. I can understand it if you don't really want to look at it carefully or not at all until after the test. That's understandable, but I can't just waste the time. I will need to go on for 9.1. Okay, so I'll begin lecture on 9.1. I introduced it last time. Okay, so we have addition formulas. Okay. Here are the new formulas to put on your next cheat sheet. You don't need it for tomorrow's test. Page 600, sine of a sum, sine of s plus t, sine s cosine t plus cosine s sine t. Sine of s minus 2 is the same thing, except there's a minus. Cosine of s plus t, cosine s cosine t minus sine s sine t. Cosine of s minus t is the same thing, except there's a plus. Okay. And even though it's written this way, you might go from right to left. I mean, these formulas go from left to right and also from right to left. Some of the homework problems, we have to go from right to left. And then the formulas for tangent of a sum or difference. Page 604. Put this on your next cheat sheet. Tangent of s plus t, tan s plus tan t over 1 minus tan s tan t. And then tan of s minus t, the signs are changed. There's a minus on the top and a plus on the bottom. Okay, so a lot of today is just recognition of the formula and then go from there. Okay. Well, here we go. 147 odd. Again, this is not due until the next exam. The next exam doesn't cover that much material. There's only, what, 7 sections? 9, 1, 2, 3, 4, and 5, and then 10, 1, and 10, 2. Okay. So again, you can take notes, but you don't need to study it for tomorrow's test. Or again, if you want to wait until after the test, that's fine. Okay, so 9.1, 1 to 47 odd, page 606. And here it is for those of you that don't have the book and aren't planning on getting it. There's that. And how far do we have to go again? 47. There's that. And there's 47. Okay, so I'll do roughly half of them. All right, so the key thing is to look for the right formula, as it were. Okay, so I'll start with number 1. Use the addition formulas for sine and cosine to simplify the expression. Okay. And I'll plan to do roughly every other one. So question number 1. Okay, 9.1, page 606. Okay. All right, number 1 goes sine theta cosine 2 theta plus cosine theta sine 2 theta. Right, it goes sine cos plus cos sine. So what you do is look up on the table. That looks like the right-hand side. Which one has sine cos plus cos sine? It's the first one. So I want the sign of the sum, sine of s plus t. So it's a sine of theta plus 2 theta, and theta plus 2 theta is 3 theta. So final answer, sine of 3 theta. Okay, that's the way it works. Okay, number 5, cosine 2u, cosine 3u. Minus sine 2u sine 3u. Cosine 2u, cosine 3u, minus sine 2u, sine 3u. Okay, it goes cos, cos, minus sine, sine. All right, so I look up. Which one goes cos, cos, minus sine, sine? Cos, cos, minus sine, sine. It's the third one. See how it works? So it's the cosine of the sum, cosine of s plus t. So cosine of 2u plus 3u, and that's the same as the cosine of 5u. Okay, so that's the way it works. All right, and how about I'll show you 7. Cosine 2 pi over 9, cosine pi over 18. Cosine 2 pi over 9, cosine pi over 18, plus sine 2 pi over 9, sine pi over 18. number 7. All right, so cos, cos plus sine, sine. So which one goes cos, cos plus sine, sine? Cos, cos plus sine, sine, that's the last one. So it's the cosine of the difference, cosine of s minus t. So cosine of 2 pi over 9 minus pi over 18. Okay, and then I get a common denominator, which is 18. So times 2 times 2. That's going to be 4 pi minus pi is 3 pi over 18. That's the same as the cosine of pi over 6. And that's something you should be able to work out. That's the kind of thing you want to be able to do on the test tomorrow. Okay, so pi over 6, I know that's 30 degrees. I draw myself a 30-degree angle. Cosine asks for the x coordinate. Now, either x or y is a half. Does it look like x is a half? No, that looks like way more than a half. Y looks like a half. So x is the other number. The other number is radical 3 over 2. So the ordered pair is radical 3 over 2, 1/2. Okay, that's the way it works. All right, then simplify the expression. So 11 sine of theta minus 3 pi over 2. Sine of a difference, sine of something minus something. So let's look back at the table again. Sine of a difference, that's the second one. So after this one, I've shown you basically one of each. I've shown you this one, this one, this one, this one. Sine of s minus t, it goes sine, cosine, minus cosine, sine. Okay. Sine of the first, cosine of the second, minus cosine of the first, sine of the second. So sine of theta, cosine 3 pi over 2, minus cosine theta, sine 3 pi over 2. Okay, so unit circle, 3 pi over 2, that's down here, 0, comma, negative 1. Again, that's something you should be able to do in a test tomorrow. Okay, cosine of 3 pi over 2, x coordinate, 0. Sine of theta times 0 minus cosine theta, sine of 3 pi over 2, y coordinate, negative 1. Okay, so 0 times that is 0. Negative cosine times negative 1 is cosine theta. Okay, so that's the way something like that works. Okay. 15 sine of t plus 2 pi. Now, we already know from before, the period of the sine function is 2 pi, which means if I add 360 degrees to an angle, I get the same thing. So I'm expecting the answer already to be the sine of pi. And yes, that is something you should already know for the test. So again, even though we're doing new material, we're kind of reviewing for the test tomorrow also. Okay, but let's use the formula. Sine of a sum, sine of something plus something. So I've shown you one of each of those already, but we're doing more, it looks like. Sine of something plus something, that's the top one. So the sine of the first, cosine second, plus the other way around, cosine of the first, sine of the second. Okay. So sine of t cosine 2 pi plus cosine t sine 2 pi, just using the formula. Unit circle, 2 pi is once around, right? So it's coterminal with an angle of 0. The ordered pair is 1, 0. Cosine means x coordinate, 1. Sine of t times 1. Cosine t times sine of 2 pi, y coordinate, 0. And you can see, indeed, I just get sine of t again. So it works, just as we expected it to. All right. 17 is a little bit tricky. They want us to compute the exact value of cosine of, cosine of 75 degrees without using a calculator. So how am I possibly going to do that? Well, I have to think of two nice numbers that add up to 75. Can you think of two quote unquote nice numbers from our unit circle that add up to 75? 30 and 45. Cosine 30 plus 45 is 75, right? So it's the cosine of a sum, cosine of something plus something. That's the third one down. See what you're doing? You're just picking the right formula. And yeah, be ready to go either from left to right or right to left. Again, not for tomorrow's test, but for the test after that, whenever that is. Okay, so it's a cosine of a sum, s plus t. So it goes cos, cos minus sine, sine. Cosine 30 degrees, cosine 45 degrees, minus sine of 30 degrees, sine 45 degrees. Okay. So go back to my unit circle. 45 degrees is right here. You should know for the test tomorrow, radical 2/2 for both x and y. 30 degrees, well, I already drew one over here, but I'll repeat it over here. 30 degrees, right? So that's radical 3/2 comma a half. Radical 3/2, 1/2. Okay, so 45 degrees, both sine and cosine are radical 2/2. 30 degrees, cosine of 30 degrees, radical 3/2. Sine of 30 degrees, 1/2. Okay, so I plug in. Remember, cosine is x coordinate, sine is y coordinate. You can put it on your cheat sheet for tomorrow. Okay, or if you had to memorize it for your next teacher, maybe it's alphabetical order. Cosine is before sine in the alphabet, x is before y. So cosine of 30, x coordinate is radical 3/2. Cosine of 45 degrees is radical 2/2. Minus sine of 30 degrees is 1/2. Sine of 45 degrees, radical 2/2. Common denominator is 4, right? 2 times 2, 2 times 2. So radical 3 times radical 2 is radical 6, minus 1 times radical 2. So final answer is radical 6 minus radical 2 all over 4. Okay. And here we go. Let me do my focus thing again. Since it seems I've gotten more blurry. Okay. All right, 21 and 23. One of those. So how do I do that? Use addition formulas for sine and cosine to simplify each expression. Okay, so 21 and 23, they're equally as easy or hard. Okay, so how about I'll do 21. It's the sine of pi over 4 plus s minus sine of pi over 4 minus s. So the first one is a sine of a sum, sine of something plus something. I use the top formula. And then the second one is sine of something minus something. I use the second one. Okay, so the first two, sine of something plus something, sine of something minus something. Okay. And this is going to be too long, so I'll scroll down to another line. So sine of the first, cosine of the second, plus cosine of the first, sine of the second, minus, okay, if I keep writing over here, it gets too long. So it's minus parentheses, sine of the first, cosine of the second, minus cosine of the first, sine of the second. It's minus the whole thing. Now, if I distribute, notice these are the same, they cancel out. These don't cancel out, they add. It's minus a minus. So I basically have two of these, right? So I have 2 cosine pi over 4 sine s, cosine of pi over 4, radical 2 over 2. So 2 radical 2 over 2 sine s, 2's cancel out. So final answer is radical 2 sine of s. Okay, that's how that goes. All right, then a little bit more complicated. They give you all this information here, sine of alpha, cosine beta, and whatever. So it kind of depends where we're at to figure all this stuff out. Okay. So let's see, 25 and 27. Oh, they're both equally easy or difficult. Let me do 25 because it has a sine and a cosine. Okay. First, it says sine alpha equals 12/13. What quadrant are we in? And yes, you will need to know this for tomorrow. If the angles between pi over 2 and pi, alpha, quadrant 2. And something about beta. Cosine beta is -3/5. Beta is between pi and 3 pi over 2. What quadrant are we in? If beta is between pi and 3 pi over 2, it's quadrant 3. Okay. Quadrant 2, all students take calculus. Quadrant 2, sine is positive, cosine is negative. Okay. So sine squared alpha plus cosine squared alpha equals 1. Sine of alpha is 12/13. 12/13 squared plus cosine squared alpha equals 1. 12 squared is 144. 13 squared is 169. 144/169 plus cosine squared alpha equals 1. Subtract 144/169. Of course, remember this is 1 is the same as 169 over 169. So if I subtract 144 over 169, that's 25. Cosine squared alpha is 25 over 169. Square root. I'm in quadrant 2. Quadrant 2, the cosine is negative. So cosine alpha is negative 5/13. And right next to it, I'll need it to plug in. Sine of alpha is 12/13. Okay, so I have that. Do the same thing here. I need sine of beta. Quadrant 3, both of them are negative. Okay, so sine squared beta plus cosine squared beta, negative 3/5 squared, equals 1. Negative 3/5 squared is 9 over 25. Subtract 9 over 25. 25 over 25 minus 9 over 25, 16 over 25. Same thing, square root. I'm in quadrant 3. The sign of the sine, the SIGN of the SINE is negative. So sine of beta is negative 4/5. And just to organize my data, let me put again the cosine of beta is negative 3/5. Okay, so I have cosine alpha, sine beta, cosine beta. Now I'm ready. Guess I should separate this right here. Okay, so I'm doing 25A now. Now that I have all my data, 25A, sine of alpha plus beta. Sine of something plus something. Top one. Sine of the first, cosine of the second, plus the other way around. Cosine of the first, sine of the second. Sine alpha, cosine beta, plus cosine alpha, sine beta. I'll just pick all this up. Sine of alpha, 12/13. Cosine beta, negative 3/5. Plus cosine alpha, negative 5/13. Sine of beta, negative 4/5. Okay, common denominator is 13 times 5, which is 65. And then 12 times a negative 3 is negative 36. Negative 5 times a negative 4 is a positive 20. So negative 16 over 65 is my answer for A. Okay, B is somewhat similar. B says cosine of the sum. (25B) cosine of, where'd it go? Alpha plus beta. Cosine alpha plus beta. Cosine of something plus something. Third one down, right? So it goes cos minus sine. Cosine alpha, cosine beta, minus sine alpha, sine beta. Okay, cosine alpha, just got to find where all these things are. Negative 5/13. Cosine of beta, negative 3/5. Minus sine of alpha, 12/13. Sine of beta, negative 4/5. Okay, and once again, I have a common denominator of 13 times 5, 13 times 5, 65. Negative 5 times a negative 3 is 15. Negative 12 times a negative 4 is a positive 48. 63 over 65. Okay. All right. Okay, then how about I'll show you something like 31, 29 and 31 are similar. 31. Let me just write all that stuff down. $31. Tangent of theta is negative 2/3. See, what quadrant are we in? Quadrant 2. Cosecant beta is 2. What quadrant are we in for beta? 0 to pi over 2, quadrant 1. Now they ask you to find all this other stuff. Okay. So how do we figure this out with this information? All right, I'm given tangent. Let's use the identity. 1 plus tangent squared theta equals secant squared theta. So we're reviewing for the test because you'll need that. Right? 1 plus negative 2/3 squared equals secant squared. Negative 2/3 squared is 4/9. 1 plus 4/9 equals secant squared theta. 1 plus 4/9 is 13/9. Let's reciprocate. Flip this, reciprocal of secant cosine. Cosine squared is 9 over 13. Square root. Theta is in quadrant 2. All students take calculus. Cosine is negative. Negative. Square root of 9 is 3. And radical 13. So we'll just leave it like that. All right, I need sine of theta. I could use sine squared theta plus cosine squared theta equals 1. I think I'll go the route of, let's see, I already know the tangent and I know the cosine. So tangent is sine over cosine, right? Tangent theta is sine theta over cosine theta. So if I multiply both sides by cosine theta, Sine of theta is the product of cosine theta times tangent theta. Okay, so cosine theta is that, -3 over radical 13. Tangent of theta was -2/3. 3's cancel out. 2 negatives make a positive. 2 over radical 13. Okay, so cosine theta, sine theta. All right, cosecant of beta is 2. Flip them. Flip that, flip that. Reciprocal of cosecant, you need that for the test tomorrow. Sine. Sine is 1/2. I'm in quadrant 1. That's the best case scenario. And you should already know 1/2 is always paired with radical 3 over 2. So automatically cosine of beta is radical 3 over 2. So finally, I have everything I need. Okay, so I have cosine theta, sine theta, cosine beta, sine beta. All right, so now I'm ready to figure out whatever they asked for. So what do they ask for? Sine of theta plus beta. Sine of a sum. A lot of flipping back and forth here. Sine of something plus something. Top one. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Sine theta, cosine beta, plus cosine theta, sine of beta. Okay, now I just find everything. Sine of theta, 2 over radical 13. Cosine of beta, radical 3 over 2. Plus cosine of theta, -3 over radical 13. Sine of beta, sine of beta is 1/2. Okay, common denominator is 2 radical 13. So this is 2 radical 3 minus 3. And you can leave it like that. Okay, I'm about to turn the paper over, so that's a good time for me to do the focusing thing again and try to unfurl for everything we've seen so far. Raising the paper up. There. And here. All right, so that's everything for that one. Okay, the problem's not finished because they also ask us for one other thing. And what was that other thing? Cosine of beta minus theta, cosine of a difference. So cosine of something minus something. That's the last one. Cosine of s minus t. So it goes cos, cos plus sine, sine. Cos, cos plus sine, sine. And unfortunately, I turned the paper over, so I have to peek back at all these. So cosine of beta, cosine of beta, radical 3 over 2. Cosine of theta, negative 3 over radical 13. Plus sine of beta, 1/2. Sine of theta, 2 over radical 13. All right, once again, a common denominator is 2 radical 13. On top, I have, what do I have? Negative 3 radical 3 plus 2. Okay, that's it for that one. All right, then we have some identities. I'll do one and then we'll break. Looks like prove the equation is an identity. Okay, so the only way to do it is just do it, I guess. 33 and 35. Okay, so how about I do 33 and you do 35 later? So 33 says sine of t plus pi over 4. Show that that's equal to sine t plus cosine t divided by radical 2. Even though they write it like that, this is what it ultimately means. Okay, now I'm used to having pi over 4 as being radical 2 over 2, so I'll use that. Okay, so this is a proof, so draw my divider. Use the formula for sine of a sum. Okay, I'm not going to show it back to you each time, I'll just go to it. So sine of the first, cosine of the second, plus cosine of the first, sine of the second. Okay, and I already know I'm going to make it look like radical 2 over 2. So here's a case where it is advantageous to rationalize the denominator by going like that. So I have sine t plus cosine t times radical 2 over 2. All right, cosine of 45 degrees, sine of 45 degrees. They're both radical 2 over 2, we said, right? So sine of t, radical 2 over 2, plus cosine t, radical 2 over 2. And yeah, that's the same thing as this if I distribute through. Okay, I got something better. Why don't I just factor out radical 2 over 2, and then I got it exactly. Radical 2 over 2, sine t plus cosine t. And there it is. They're equal. And again, that will help us for proof. So we're setting you up for the test tomorrow in case I give you a proof. This is how you set it up, right? Prove the left side is the right side. Draw yourself the line. Work on this side, work on this side. Hopefully you get them equal. Okay, so there's that. And there's that. Okay, so we'll take our usual break. I'm actually almost done with the section. So after the break, I'll go a little bit longer and then I'll stop. And then if anybody wants to ask for questions for review for the test tomorrow, you may. And you should have gotten a Canvas announcement from Mackenzie. I think Mackenzie had a review session for later this afternoon if you're interested. you can go to that also. Okay, so we'll take our normal break and start again at 12:10. All right. Okay, folks, let's continue on where we were. So I will not be going that much longer. You have some problems involving the tangent of a sum and difference. So get those out of the way. All right, so it looks like I will be done with section 9.1 today. I will just introduce the formulas for 9.2. Then I'll stop, let you ask questions. Okay, so tomorrow I'll lecture a little bit on 9.2. Then we stop. Then you can ask questions. We break, and then we take a test. Okay. So calendar-wise, it looks like it's going to be like this: 9.1 and some of 9.2 tomorrow. Okay. And I would only be quote unquote a little bit behind, but again, we're really ahead because I had like, seems like maybe 8 days, and looks like I've given up maybe 1.5 or 2 days. And so I'm intentionally slowing down because we have all these extra days here. Okay. All right, so before the break, I left off on 33. And the remaining problems involve formulas for the tangent. Okay, and you can't see it that well. So now we're using these formulas. Again, don't put these down for your test tomorrow. Just look at these after the test. For the tangent of a sum and difference. These guys here, page 604. Tangent of s plus t. Tangent s plus tangent t over 1 minus tangent s tangent t. Tangent of s minus t. Tangent s minus tangent t over 1 plus tangent s tangent t. Okay. All right, so that's like 37, 39. Okay, I'll do 37. Tan s is 2, tan t is 3. Tangent s is 2. Tangent t equals 3. Right, so they want the tangent of the sum. Okay, so that was the first formula I showed you. Okay, I don't feel like turning back to it. I'll just go ahead and give it to you. Tan s plus tan t over 1 minus tangent s tangent t. Plug it in. Tangent s is 2. Tangent 3 t is 3. 1 minus tangent s tangent t, 2 times 3. That's 5 divided by 1 minus 6 is negative 5. So negative 1. Answer is negative 1. Okay, then you want tangent of s minus t. Is that right? Yeah. Okay, so formula for that is tangent s minus tangent t over 1 plus tangent s tangent t. So just plug in again. Tangent s was 2 minus tangent t is 3 over 1 plus tan s tan t, 2 times 3, negative 1 divided by 7. That's all. $39, they make you jump to one more hoop. It's not quite like 37. They don't give you tangent of s, they give you s, and they give you tangent t. So the only hint I'll give you for 39, this is good preparation for the test tomorrow. Okay, so 39, I'm not going to do it, but it's just a hint. So I'll just say 39 hint. S equals 3 pi over 4. 3 pi over 4, pi over 4, 2 pi over 4, 3 pi over 4 is right here. Remember, for all the angles that have a reference angle of 45 degrees, both x and y are radical 2 over 2, radical 2 over 2. And second quadrant, x is negative. So negative radical 2 over 2, radical 2 over 2. So the ratio is 1, negative 1, sorry. So tan s is negative 1. So the tangent of 3 pi over 4 is y divided by x. Radical 2 over 2 divided by negative radical 2 over 2 is negative 1. Okay, so once you have that, I'll just say et cetera. The rest of the problem is just like 37. So later on, not tonight, after the test, if you want to finish the rest of that problem, the rest of the problem is just like 37. Okay. All right. Then let's see, how about something like 41? Tan t plus tan 2t over 1 minus tangent t tangent 2t. Tan plus tan over 1 minus tangent times tangent. Okay, so that looks like the first formula, tangent of a sum. Let's see if I can find that for you here. So that looks like the right-hand side of this. Tan plus tan over 1 minus tan tan. So it's a tangent of the sum. And t plus 2t is 3t. So tangent of 3t. Okay. That's all for that one. I'll show you 43. Tangent 70 degrees minus tangent 10 degrees over 1 plus tangent 70 degrees, tangent 10 degrees. So minus, that looks like the second one, right-hand side. Tan minus tan, tan s minus tan t over 1 plus tangent s tangent t. So it's a tangent of the difference, tangent of the first minus the second. Well, that's 60 degrees. Tangent of 60 degrees. You might have that on a test tomorrow. And I get that without a calculator. 60 degrees. Either x or y is a half. There's y, more than a half. X looks like a half. So x is a half. 1/2 is always paired with radical 3 over 2. So tangent is y over x, radical 3 over 2 divided by 1/2, which is radical 3. Cancel out the 2's, radical 3. All right, last one, folks, then I'm done. So I'll sneak in just a very little bit of 9.2, and then that's it. So I should be done within the next 10 minutes, probably less. So if you have any questions in preparation for the test, be ready to ask then. If not, then I'll just let you leave. And then tomorrow I'll lecture a little while, question and answer, then we take the test. Okay. Day 1, tangent of 7 pi over 12. And they're telling you it's a tangent of pi over 3 plus pi over 4. Use that. In other words, pi over 3 plus pi over 4 is 7 pi over 12. We can verify that quickly. Pi over 3 plus pi over 4. Common denominator is 12. So times 4 times 4 times 3 times 3. So yes, 7 pi over 12, right? So I use the formula for the tangent of a sum, tangent of something plus something. Top one, page 604. Tangent pi over 3 plus tangent pi over 4 over 1 minus tangent pi over 3, tangent pi over 4. Pi over 3 is 60 degrees. I'll just speak over here. We had that as radical 3. Pi over 4 is 45 degrees. Both x and y are radical 2 over 2, which means y over x is 1. This is 1. This is 1. Tangent of pi over 3, radical 3. Radical 3. So I have radical 3 plus 1 over 1 minus radical 3 times 1 is radical 3. Okay, that's essentially it. It's just a rationalized denominator. I won't bother with it. We'll just leave it like that. That's good. I guess if you want to make it look nicer, maybe 1 plus radical 3 over 1 minus radical 3, and we'll leave it like that. Okay. All right, I am officially done with 9.1. I'll just give you the formulas for 9.2. Okay, it will only take me a few more minutes. Then I'll start doing some problems from 9.2, but I won't get that far tomorrow. I can save that for next time. Okay, so 9.2, page 611. We have the double angle formulas, twice an angle. Here they are. I'm going to put this on your next cheat sheet, not for tomorrow, but for the test after this. Sine of 2 theta, 2 sine theta, cosine theta. Cosine of 2 theta, cosine squared theta minus sine squared theta. Tangent of 2 theta, 2 tangent theta over 1 minus tangent squared theta. They're all easy to prove if you treat 2 theta as theta plus theta, and then use the sum formulas that we just had. Okay, so I'll show you those, and then I'll be pretty much done. Okay. So sine of 2 theta, I can treat it as a sine of theta plus theta. And we have the formula for that. I mean, if it works all the time, it has to work in this case too. So it's the sine of the first, cosine of the second, plus the cosine of the first, sine of the second. But these are the same thing. So I have 2 of them. So 2 sine theta, cosine theta. So that's a little mini proof that the sine of 2 theta is equal to 2 sine theta, cosine theta. That's the first one there. Do something that's similar for number 2 and number 3. Cosine of a double angle. 2 theta, you can think of as cosine of theta plus theta, which by formula is cosine of the first, cosine of the second, minus the sine of the first, sine of the second. That's cosine squared. That's sine squared. So cosine squared theta minus sine squared theta. And that's the second one. Number 2. And finally, number 3. Tangent of 2 theta is the tangent of their sum. So if the formula works all the time, it should work if the angles are equal. So by formula, tangent of the first plus tangent of the second over 1 minus tangent first, tangent second. So on top, tan theta plus tan theta, 2 tangent theta over 1 minus tangent theta times tangent theta, tangent squared theta. And that's the third one down right over there. Okay. Right, so tomorrow I'll be starting off with some problems from 9.2. 1 to 51. So maybe I'll just go ahead and show you the problems for those of you that don't get the book and are planning to. So 9.2, page 616, 1 to 51 odd. So there's 1, 3, 5. Some more there. Some more there. Okay, there's a lot of stuff here, as you can see. So we won't get that far. And some identity problems, a little bit harder. Okay. Yeah, that's pretty much it. All right, so we're done, folks. So I'm going to stop the share. So class is officially over. If you want to stick around and ask me questions in preparation for the test, you may. If not, prepare for the test. You may start turning the homework even now if you want. Okay, I'll stick around with Star. If you have any questions, you can ask Mackenzie or Star or me. And remember that Mackenzie has a review session this afternoon, I believe it was. If you want. Okay, so you can leave or you can stay and be ready for the test tomorrow. Okay, so I'll give you a few minutes to stick around if you want to ask stuff and be ready to ask us any questions. Okay, all right, otherwise I'll see you tomorrow. All right, Star and Mackenzie, it looks like everybody left. So we're done except for Tara. Tara, are you there? Tara, did you have a question? Maybe she's not responding. I'll type it in the chat also. Let's see. Tara, did you have a question? Okay, Mackenzie, as I recall, you do have a session this afternoon. Is that correct?
Yeah, I do it at 1:30.
Okay. And Star, I think you said you weren't able to. You have your own things to take care of. Is that right? Okay. Then I don't hear anything from Tara, so I'm assuming that we can just quit. And okay. And thanks again, Mackenzie, for your helping out there. Tara, one last chance. Tara, are you there? Okay, I'm going to close the session then. All right, everybody. So thanks, Mackenzie. Thanks, Star. We'll see you next time.
Okay, see you later.
Right, see ya.
See you later. Bye.